Morning to one and all. Today we are going to solve a circuit on this star delta transformation. Take down this problem. Find the effective resistance across the terminal A and B. So one network is given. So A, B, and C. So we need to find out the effective resistance across the resistance A and B like that given. So by seeing this circuit itself, we can understand this is somewhat related to star delta network because delta type is there, here star type is there. So in either way you can solve. So here what you can do is you can convert this star into delta, means you can easily further simplify and you can easily solve the problem. So what I am doing is we are just taking out this star network outside. Okay, this 2 ohms, 30 ohms, and 8 ohms is then we are taking out the star network outside. Now with this star network, we are converting that into delta. So how to convert the star into delta, the sensor? Say for example, this star network we have taken outside. Now this we are taking as RA. We are taking this as RA, RB, and RC. So RA is equal to 2 ohms, RB is equal to 30 ohms, RC is equal to 8 ohms. Now we need to convert into this delta network as R1, R2, and R3. So what is how to find out R1? R1 is equal to this RA into RB plus RA into RB plus RB into RC plus RC into RA divided by, so we are finding out R1, no? So in this particular part, whichever is not that, you have to come in the denominator. That is the formulation already we have seen in our previous classes. So R1 is equal to RA RB plus RB RC plus RC RA divided by, that is the combination of all the resistance multiplication, and also we are adding it, plus divided by whichever is not that will be coming in the denominator, that is RC. So now RA, RB, just you have to substitute it. That is RA is 2, RB is 30. So 2 into 30 plus 30 into 8, RB is 30, RC is 8. So 30 into 8 plus RC is 8 and RA is 2. So like that we are substituting, and divided by RC is nothing but 8 ohms. So further simplification, so you'll get this part, numerator part around 316 divided by 8. So that is nothing but R1 is nothing but 39.5 ohms. Similarly, R2. How to find out R2? The same thing. R2 is equal to that combination of all the resistance. You need to add, that is RA RB plus RB RC plus RC RA divided by this R2 you are finding. So whichever is not there. So RA is there, RC is there. Whichever is not there, that will come in the denominator. So this is not there. RB is not there. That will come in the denominator here. So that formulation, that just a substitution, because this formulation already we calculated RA, RB, RB, RC, RC, RA already we calculated as 316 ohms. The same thing we are entering here, or otherwise if you want to calculate once again, you calculate it, verify it. Same thing it will come. So 316 divided by RB. RB is what? Here 30 ohms is there, just substituting 30 ohms here. Then now we are finding out R2 is equal to 10.53 ohms. Now we are finding out R3. R3, how to find out R3? Same combination of all the resistance we need to add, that is RA, RB plus RB, RC plus RC, RA divided by R3 we are finding out, divided by whichever is not there, because if you take this R3, these two are connected, RB and RC. This RA is not connected, so divided by R. So that we are taking here. So this already we have answer, that is 316 divided by RA is 2 ohms. Okay, just simplifying, we are getting R3 as 158 ohms. Now we converted this star network, that is whatever we had taken out, no, this star network, that is 2 ohms, 30 ohms, and 8 ohms, that star network into this delta network. So R1 is what? R1 is already we saw 39.5 ohms, R2 is 10.53, R3 is 158. So just we are substituting R1 is equal to 39.5, R2 is equal to 10.53, R3 is equal to 158 ohms. Now adding these delta network with the main circuit, whatever it is shown in the figure. Now this network we converted, this star network we converted to delta. Just we are adding in this main network. Now, after adding, we are getting the circuit like this. Now you see this two 20 ohms and 39.5 ohms and 158 and 50 ohms and 30 ohms and 10.53 ohms are individual. These two resistors are in parallel. Okay, it is connected in the parallel formulation. So 20 ohms and 39.5 ohms are in parallel. So 20 into 39.5 divided by 20 plus 39.5 will give you the answer of 13.27 ohms. Next, similarly here this two 10.53 and 30 are in parallel. 10.53 into 30 divided by 10.53 plus 30, it is 7.79 ohms. Similarly, 158 and 50. So 158 is parallel with 50 ohms. So 158 into 50 divided by 158 plus 50. So we'll give you the answer of 37.98 ohms. So this further we are solving the we are calculated, no. So that we are adding like this A, B, and C, because that network points are given as A, B, and C. Yeah, this is A, this is B, this is B. Because after reducing, we are getting like 13.27 here, 13.27, 7.97, 37.98. So 13.27, 7.979 and 37.98 ohms. So what they asked in the problem, effective resistance across the terminal A and B. They asked, yeah, this is A, this is A, and this is B. Effective resistance across this A and B is nothing but 13.27 ohms. So this is the answer for this particular RAB. That is between A and B is 13.27 ohms. So this is the answer for this particular star delta network shown in the figure. So very simple, you can solve, but the only thing is formula you have to remember. Converting star to delta, this is the formula. Okay, delta to star also formula is that we'll see in the next problem. Thank you.